formed into tan is sine over cosine, which can become secant x over cosecant x. If you include the ratio identity with reciprocal identity, you can create this identity. Does that make sense? Okay, and if this is tangent, then that makes cotangent what? The reciprocal of that, right? Okay, so that's why you need to know the basic ones, because if you know the basic ones, you can make multiple identities. I can zoom in so that Destiny can stop squinting, along with Ty. You and Destiny in the squinting.
Talk bad. I would say so.
He's not worth it. He has a whole nother year to deal with me. Lothar. Right here? Right here? Okay, because of the reciprocal identity. With the reciprocal identity, remember sine is 1 over cosecant, right? So this could become 1 over, guys, over cosecant, and cosine would become what? 1 over secant. And then, how do we divide fractions? We do what?
Keep, change, flip.
Keep. Change. And then we're going to? And what happens, AJ? So when we combine the ratio and the reciprocal identity together, that's how we can create these extensions of these two identities. Capiche?
Hold on, I'm right there.
I will. Did you need me, senor? Okay. Got it? Yes, no, maybe so? Yeah. All right, so can we put a check that we understand the ratios? Yeah. All right, checking. So that is now 5 of our basic 8s that you were telling me we're good to go on with. Yeah. 5 of them? All right, last 3 of the basic 8 that we covered. Pythagorean identities. Okay, remember these are the parents. And each parent has 5 kids. And what those 5 kids are, all the different ways to manipulate them, right? And we wrote them all down on page 11. Is that what it says, Evelyn? Where it says Pythagorean identities? All right, so on page 11, we wrote each parent's 5 kids, correct? So these are the parents, and they can be manipulated.
Oh, yeah.
Into how many things again?
5.
We're going to call them their kids.
So this is parents manipulating kids instead of kids manipulating parents.
Yeah, the way the world should go.
I'm good with this.
Okay, so if I had a problem and it wanted cosine squared by itself, what would I have to move?
You got to
Subtract sine squared.
from 1.
Beautiful. If I had a problem and it wanted a -1 from tan squared and secant squared, what would I need to do?
You would subtract the 1. secant.
Time out. Go, Joey. What'd you say?
Subtract the 1 and then subtract the secant.
There we go. So we can move our parents around. The parents are being manipulated in order to create the kids. I know that sounds weird, but that's what's happening. Okay? Are we good with those? Because those are our basic 8. And I'm going to test if you're good with them because we're going to have practice problems over them. And there's similar practice problems that we've done for the past week and a half. And if you're able to do them, then we're good. All right, so checking that you said you're good right now. All right, real quick. We're not going to focus a whole lot on odd and even identities at this time. We're going to revisit them when we revisit trigonometry. But I just wanted you to have a glimpse at them. With odd and even identities, you have sine. And if you have the negative angle, what this is telling you is because sine is the y value in our x-coordinate, it's a dependent value, right? It's a dependent value, which means that it's the weaker variable. And because it's the weaker variable, it's always going to be the most consistent. And remember, x is our independent variable, and that's the one that's always changing. That's constantly changing. So This is our weaker variable. Therefore, whether it's the negatives on the inside or on the outside, it's going to always be negative. It's going to stay consistent. Because remember, x comma y on the unit circle represents cosine comma sine, if I can write. And way back in algebra, you learned that x is your independent and y is your dependent. And independent is the stronger variable, and dependent is your weaker variable. Got it? All right. Cosecant and sine are related. How are they related? I heard it? They're reciprocals of each other. And so if this is a weak variable, then its reciprocal is also a weak variable. So it doesn't matter if my negative is on the inside or on the outside. All right, cosine is our strong variable. Cosine is saying that it's our independent variable. So when cosine changes or alters, it's going to be the total opposite of itself. So if it's negative on the inside, that means my output's going to always be a positive. And because secant is its reciprocal, if it's negative on the inside, my output is going to be a positive.
What if it's a positive on the inside? It will be positive?
Yeah, it's going to be positive. But the positive is kind of given that it's always going to be a positive. Okay? And that goes back to the unit circle. When you have a positive angle, notice how things were. And then here we have tangent. Tangent comes from the creation of sine and cosine, right? And because tangent comes from the sine and cosine, that just goes back to basic algebra. If I have a negative and a positive, my result's going to be a negative. Because a negative times a positive is a negative. And that's why tangent follows the negative rule. We agree? Okay. That's it for odd and even, really. Odd and even is really not, I don't know how to further explain it. It's pretty basic. Inside, outside, either negative or positive. All right, confunction properties. Confunction properties we're not going to get to in high school pre-cal at the rate we're moving at, but when you go to college pre-cal or college trigonometry, you will address the confunction properties. Confunction properties are just saying that if you have the sine and you subtract that value, that angle from 90 degrees, it'll automatically give you the cosine. And the reason why I'm saying 90 degrees is because pi over 2 equals 90 degrees. Okay? And the same rule is here. If I have cosine and I want to find the sine, I can subtract pi over 2 from x and I would have sine x. So your example would be, go. All right, so let's say I put in the cosine of, someone give me an angle. 45?
Yeah. 0.
All right, 45. Is that a good one? That's fine. It's pi over 2. And I get, what's the problem here? Can someone tell me? Is it 0? No, it's not. My calculator is in what?
It's not in radians. I'm in degree.
I clicked the wrong button. Doc?
Change it.
It's in radians. It is in radians.
Then it's, I guess it is right.
Am I rounding? I wrote radians. I wrote it in radians. Why is it round? Okay, let's just try degree. Make default. Aye, aye, Captain. That's what it's supposed. And then I wrote a radian. This has not done this to me all day. Okay. It's supposed to be that because the cosine of 45 is the square root of 2 divided by 2. And I know this because I know my unit circle. Okay? The cosine of 45 degrees is the square root of 2 divided by 2. And so what this is telling me is that if I do sine, if I put in sine, and I write 90 degrees minus 45, I should get the same answer. And do I? Okay, that's why they're saying that these are equivalent. That's the confunction properties. That's all it simply is saying. Is it cofunction? Confunkshun properties. Lo siento. Alright, so you'll address that later. Now, I just want to give you a glimpse of what we're doing tomorrow. So tomorrow we're going to sum and difference of identities. I think a lot of you guys will be happy because our results will actually be numerical. It's not just going to be sine, cosine, tangent, secant, blah, blah. We will also have numerical results. So I think you'll be a little happier because you will feel a little more comfortable because there's a way that you can actually check your calculation, right? So this is tomorrow's. Tomorrow is what day? Thursday?
Tomorrow's Thursday.
Tomorrow's Thursday. Okay? The only thing is that we're pausing to do the tangent till Monday. So the tangent portion of this we're going to do on Monday. Friday, except my juniors. Juniors, you will be at a elective fair. An elective fair in the gym.
Some of us won't be here anyway for seniors either.
Why won't seniors be here?
You CIS, you want to,
After lunch.
okay, never mind.
I ain't going.
No, y'all are leaving at 12:30.
Never mind.
During your free time. Look at that. All right. Double angle identities. We're going to do this on Friday. So for my 4 juniors, guys, you guys, if you want to stay and do the lesson, you can stay and do the lesson. Who's? Oh, Dulce and Megan. Right. There's 6 of y'all. I only counted these 4 because I was looking at them. I didn't count you and Megan. All right. However, on the tangent one, we're going to hold off until Monday. All right. Then half angles we're going to learn on Tuesday. Okay. So next Tuesday we're going to learn half angles. And again, half angles are going to give you a numerical value. I think the next few identities you will feel a little better about because you're going to end up with a numerical value. Which I think you guys will like. Maybe, maybe not. We'll see how it goes. All right. And then at the bottom, on Wednesday, you're taking a group quiz.
I got Alexander.
You're already in your groups. You chose these lovely groups yourselves. Wednesday, you have your group quiz. And then following the group quiz, we have our test review. Your test review is not a grade, nor is it extra credit. On your test review, it's practice problems, and I've included the answers so that as you're practicing, you'll have those answers available to you. Okay? I'll probably give you your test review on Tuesday so that you can get a head start. Yes? No, I moved the quiz because you guys wouldn't be here, and then yeah, and it's a half day. It was just easier to move it because we have staff development. That's a test review, and then guys, because I want you to do really well on this quiz and I want on this test, I want you to take your time. We're gonna have 2 days of testing. Happy Valentine's Day. So your test will be Thursday and Friday.
This Thursday?
Next. Let me write the word next so I don't confuse some people. Okay, so yes. Okay, you can come after school to start on it, or however you want to work it, or stay after school on Monday to finish it. Monday. You can stay after school on Thursday to start it and finish it on Friday in class, or you can start it on Friday in class and stay after school on Monday to finish it. Y'all are going to the bank place, right? The money place, the Federal Reserve. There it is. I was getting there. All right. Okay. Let's see if you say you're good with the basic A. Let's put you to the test. I don't know if y'all are just putting on a show, but you said you're ready. So what I did is I typed up a checklist for you. So on the checklist, First thing you should look and see is it approved? Is it approved? Does it want you to simplify? Or does it want you to factor? Okay, you got to look and see what the problem's wanting you to do. If it's wanting you to do a proof, then you're going to choose the more complex side, which is typically your left. If it's simplify or factor, then you're going to go on to the next steps. Okay, next step is look for algebraic manipulations. So add fractions, aka chopsticks in a bowl.
For real?
Okay, so if we're trying to find a common denominator, the fastest way to do it is with chopsticks in a bowl. Okay, then look and see what you can factor. Are there some basic factoring rules? Like, for example, if I have a squared minus b squared, that's going to automatically become a minus b and a plus b. Look and see if there's a greatest common factor. Is there a GCF I can take out? Those are key things to look for when you're factoring. Okay? And then next other thing that you should look for algebraically is multiply out. Multiply out is just another way of saying distribute. Is there anything you can distribute together in order to create one of the basic 8 identities? Then you have look for trig substitutions. Look for the basic 8 identities. Is there a reciprocal present? Is there a ratio present? Is there a Pythagorean present? Look and see if are any of those there before you do the next thing. And then the next thing is, if nothing can happen after you've done that, change everything into terms of sine and or cosine. What you guys keep trying to do and making yourself work harder is the very first thing you do is make everything sine and cosine. Okay, that's making the problem harder for you. If you do the algebra first, look for already given identities, and then do the sine and cosine, it'll make the problem a lot easier for you. Okay? And then the final step is check again for Pythagorean identities. If you see anything that's squared, check and see if it matches the Pythagorean identity. And then the final step is keep looking at the answer and identities. Okay? Just listing these out in like a type of a checklist, does that help you a little bit?
No. Yeah.
Because we're gonna do the checklist. Alright, let's start with number 1.
Right here.
No, not talking about the one you was right there. Oh, I got it. I didn't see it.
Boy, you
I didn't get out my what?
That is,
What does this problem want me to do? Okay, it wants me to multiply it and simplify, right? So when it wants me to simplify, that means I'm going to skip on down to the algebra aspect of it. What is it telling me to do algebraically? It says I have 2 of them, not times 2. It's telling me that I have 2 of
You
them.
have 2 of them.
Tan theta plus 1.
This little square tells me that I have 2 of them.
Yep.
How many ways do I have to solve this?
foil.
6.
I have 2, right? I can either foil or box, not cap. Foil or box. When I foil,
That's tan squared theta.
it's going to take that effect. If I choose to box, I have tan plus 1, tan plus 1. It's just like the Punnett square in biology. What's tan times tan?
10 squared.
What's tan times 1?
2.
Tan times 1? And what's 1 times 1? And now you combine like terms, and the only like terms are? And how many of them are there?
2.
So my answer is tan squared theta plus 2 tan plus 1. Okay, so you either can FOIL to get this or you can box to get this. You're going to get the same result. We agree? All right, what's the next step? We've done our algebra. What is our next step on our checklist?
Look for the manipulation.
Look for trig substitution.
Tan squared plus 1.
There you go. I can combine tan squared and the
1.
positive 1, and what do they create?
That creates cosecant square. I mean secant square.
I ain't my note card, man.
We made no cards?
No, come on, my note thing is my journal. There's another one. So I keep it with me.
Take your journal.
Don't you just
If you didn't turn it in yesterday, I said at the end of class, I'm going to need it. And that's it. I can't go any further, can't do anything more. The party has ended. How do we feel? Good? All right, let's go on to number 2. All right, is this a prove, factor, or simplify? It's a simplify. Okay, so I want to simplify this. Next thing, look at what's algebraically possible for me to do. Algebraically, what would I do?
A squared minus b squared equals parentheses.
Exactly. At this point, I can either do FOIL, or I can realize that this is a plus b times a minus b, which just simply equals a squared minus b squared. And I just got to plug in those values. So what is a?
secant squared theta.
And what is b?
Squared theta minus tan squared theta.
And I can use now, what is this? It's an identity, right?
Yes.
And what's the answer to this identity?
1.
Uno. Now, if you can't see that manipulation, well, on our identity chart that I just gave you, it tells us that secant squared theta is 1 plus tan squared theta. And what's going to happen to my tangent? They're going to go away. Because a positive plus a negative of the same thing is 0. And so either way, I'm going to end up with 1. So it doesn't matter how you get to that 1. The answer is 1. But if you remember this rule, it eliminates you having to FOIL and box. Okay, we're going to simplify some more on the back, but how do we feel right now? Okay, we're going to now move on to factor. So on factor, it says that one thing that we should look for first is okay, is there a greatest common factor?
Yes.
What's the greatest common factor for sine and cosine? Oh, I knew. Yeah, it was a good one. Good one, AJ. All right, what I have here is a squared minus b squared. And I know when I factor it, it's going to become what? And a minus b. I just got to figure out what a and b are. Mathematically, to find a and b, what you're doing is you're taking the square root of the terms. So what's the square root of sine squared? And to find your b, what's the square root of cosine squared? Now, do I know my a and my b? So I just have to plug them in. So I have sine theta plus cosine theta, or you could do the minus first, times sine theta minus cosine theta. And there is my factored form. When you're factoring something, you want to take it from being small to expanding it out. The reason being is that if this was the numerator or denominator of a problem, now could I start eliminating things? Yes, because I'm not just strictly adding or subtracting. I'm now also multiplying. All right? 4. 4 is factorable, but you have to think about it as a quadratic. Okay? Exactly. So you get your ax squared minus your bx plus your c.
Wait, hold on.
Quadratic. They go together. All right. So by using this quadratic formula, what is x is equivalent to what then? Cosine. So at this point, I have the choice to work it as a trig problem or to work it as a algebra problem. What are you stronger at? Algebra. So work it as an algebra problem. So wherever cosine is, I'm going to plug in a x. So here I'm going to have x squared minus 2x plus 1. Do you guys know how to do that?
Yes.
You either can do CAB, you can do quadratic, you can do mental factoring, but you guys know how to do this problem. Okay? You should know how to do this problem from algebra. Okay? If I was to do CAB, this would be my C term, this would be my A term. So CAB is C times A equals your B. The factors equals your B. So what's 1 times x squared?
X squared.
And what is my B term?
2x.
What kind of 2x? Alright, so what times what gives me x squared, but adds to give me a negative 2x?
Negative x times negative x.
There you go. A negative x times a negative x equals, do we agree? Okay. Do we agree that negative x plus negative x also equals negative 2x? So therefore, this is what we would call, or what I call, your magical number. Yeah, once in the end. So when I take them to the first box is always your A term, and my A term is x squared. The last box is always your C term, and what are your magic numbers that go inside? What's their greatest common factor? Are y'all remembering this from algebra?
X.
What's their greatest common factor? Why isn't my colors changing? Their greatest common factor is 1. Their greatest common factor is? Their greatest common factor is? Now you're going to think about the signs. How can I get a negative here, and a positive?
Negative.
The ones are negative.
They both have to be,
Negative.
because a negative times a negative will give me a, but a negative times a positive will give me a. So now, if these are my factors as x is minus 1, but what did we say we were substituting x for?
Cosine, so it'll be cosine minus 1 and cosine minus 1.
There we go. You know how to do this, guys. Like, it's in you. You've done this before. But because we added cosine, sine, tangent, you're now freaking out and saying, what is this? This is not algebra. It is. It is. I promise you. I'm not tricking you. It's not a setup. But did we not just solve an algebra problem? We did. That's it. Excuse me, Don? I don't know what you're saying. Don. You make me laugh. All right. What are we doing here?
We're dividing by 10.
It's a factoring, and we can use greatest common factor. What is the greatest common factor between these two terms? What do they both have? 10. When you're factoring something out, you're not eliminating it. You're bringing it to the outside of the parentheses. What's tan divided by tan?
1.
What's sine theta times tan theta divided by tan theta? I've now factored by greatest common factor.
Wait, can you turn that into the Pythagorean Identity?
Is there a square in there, Don? Look at that. Okay? The same thing as if, okay. So, Destiny, if I asked you x squared plus 2x to the 4th, and I asked you, Destiny, what's the greatest common factor of that algebra problem? What would you tell me? Huh? You would tell me x squared, okay? So I'm going to factor out that x squared, factor out the x squared. It doesn't disappear. It moves to the outside of the, and what am I left with on the inside?
2x squared.
What's x squared divided by x squared? And what's x to the fourth divided by x squared?
It's like 2x squared.
2x squared.
This is all we did.
That's it.
That's it. That's all we did. Except we threw the word tan and sine.
Alright.
He being kind, man.
But do y'all see that? How it's the algebra you know just tied in with the trigonometry. Okay? Alright, here. 6. We're factoring. How will we factor this?
1 minus sine squared theta parentheses squared.
Would you break down the sign into like the two squares to get that 4?
Kind of. What if you have, don't you have a squared minus b squared?
Oh my god.
Can I take the square root of 1? Can I take the square root of sine to the 4? So I have that, which means that it can break down to, I just have to figure out what a and
B.
so how do I find a and b?
Square root.
I take the square root of both terms, right? So to find a, it's the square root of the first term. What's square root of 1? To find b, square root of the second term. What's the square root of sine to the 4th? Sine squared. So now I know my a and my b, so I just have to plug them in. So 1 minus sine squared theta times 1 plus sine squared theta. So at this point, what else can I do? Are there any trig identities that's happening? Is it okay? One of them is a Pythagorean, but this is still a what? This is still, is that not still an a squared minus b squared? So we got to do it again. So to find a, I'm going to take the square root of the first term. What's the square root of 1? To find b, I'm going to take the square root of the second term. What's the square root of sine squared? Sine theta. And then what's the Pythagorean that this will become?
Cosine
Cosine squared.
Tangent.
Just cosine squared theta?
Square. No, plus
Cosine
1.
squared theta.
Yes.
What about negative cosine squared?
They gotta be the opposite, right?
Is it negative? Is it positive?
Oh
What
yeah,
is
it's negative.
It's positive.
Oh no.
No, it is negative.
Are you tripping?
It's a negative, right?
Negative, you have to subtract the 1 and the cosine.
There we go. So when I look at this problem, let's go look at it. So I want sine to be positive and 1 to be positive. Is that possible? What would I do?
Why didn't you just put it like this?
Subtract the cosine to the other side, then you subtract.
Okay, so subtract the cosine to the other side and then subtract the 1. So now I have sine squared x minus 1. Is that possible?
So yeah, so you start off with a negative, so you're going to end with a negative.
Huh?
Start off with a negative, you're going to end with a negative.
No, you start off with a positive and you move it, you're going to end with a negative.
There's a problem that
So is there really a Pythagorean that we can use? No. So be conscious and aware of that. Just because it's squared, does that mean it's a Pythagorean? No.
So you lie to us.
You're supposed to stop the lies.
So the not one is the
What are we
Pythagorean.
learning?
I agree at HA.
So is this really a Pythagorean?
No.
No. It's not.
So you lie.
But can we still do that?
This one, it wants us to factor. It doesn't want us to simplify, so that's why we're going to keep moving forward. So now I have, what is that?
1 minus sine theta,
And
1
1
plus
plus
sine theta.
then I'm just going to bring down,
1 plus sine squared.
because there's nothing I can do with it, right? There's nothing I can do with it. It tricked me to try to make me believe it was an identity, but it wasn't.
So is it?
Tried to get me for my goodies.
Oh my God.
This is the problem with the hip-hop culture. It takes all words that people use in normal life and transform them into other things.
No,
I've never
no,
heard
you
anybody
can't, no.
use the word
Justify yourself.
Have you heard that song?
She meant
We done
so.
man, all
Like,
Like my elementary teacher used to say, guys, I have goodies for you all. And now, if an elementary teacher said that, people will be seriously confused.
Oh, you can't justify yourself now.
Like, that's the crazy thing. And if you read the Hansel and Gretel story, you know, like the witch tells them, I have plenty of goodies for y'all. But then y'all ruined the fairy tale. All right, let's do number 1 together. You said you got your basic 8 down, right? Step 1 is what? What are we doing now? Okay, but what is this? It's a proof. It's a proof, right? It's a proof because I have this equal and I want to prove that. Okay? Step 2 is because it's a proof, I'm only changing the what side? And the right side is my keeper. It's my goal, it's my keeper, is what I want to stay. Okay? Step 2, now let's look at algebraic. First algebraic we should look at is common denominator. How do we get a common denominator? Alright, so my first chopstick. 1 times 1 plus secant.
2 plus secant squared.
1 plus secant.
1 plus secant.
Because anything times 1 is it? My rice is? My other chopstick to hold my rice is?
1 minus secant squared.
And then my bowl that holds it all together.
Is that like 2?
My bowl that holds it all together is a minus b times a plus b, so it becomes what?
1 minus secant squared of x.
So it becomes an a squared minus a b squared, which is what?
1 minus x.
There we go. All right, so we did our algebra. Almost done with it. So let's start simplifying our algebra. Numerator. What can happen in my numerator?
You can take out this 1 minus secant.
There's 2 secants on 1 on 2.
There's not 2 of them. It's not parentheses squared.
The 2 secants cancel out?
The 2 secants are going to cancel themselves out, right? Because I have a plus secant and I have a minus secant. So they're going to cancel themselves out. And I'm just left with 1 plus 1, which is?
2. So it'll be
Okay.
2.
So we 2 over 1 minus secant squared of theta. I mean, it's x.
Okay? Does everyone understand what happened here? All I did was combine like terms. Haven't did anything, haven't did any trig, just did algebra. We combined like terms. Good?
1 minus secant squared is tangent squared.
What kind of tangent?
Tangent.
It's a negative tangent squared. Okay? So this is going to become 2 over,
Tangent, negative tangent squared.
and this is y.
And then the tangent would become cotangent 1 over cotangent.
Good job. All right. So I think for some people it's hard for them to visualize, all right, this 2 and this negative can automatically be separated. They can. Negative, it doesn't matter if your negative's in the numerator or in the denominator. Because as long as there's only one negative, the whole problem is negative. So I can separate that negative and that 2. And when I separate them, I'm just left with my trig value.
Which is 1 over 10.
Danquise, you can't see with your hands over your face. Okay, and 1 over 10. What is
Which is cotangent squared.
Why is it cotangent squared?
It's a reciprocal.
There we go. And this is because it's a...
Wait, are we just going to forget about the negative 2? Oh.
I didn't forget about it.
Everyone, I didn't forget. It's a negative.
So why can you take apart the negative?
Why can you take it apart? The reason why you can take this apart is because if I had negative 2 over x squared. Got it? Negative 2 over x squared. It's equivalent to me saying negative 2 over 1 times 1 over x squared. Is that not true?
Nope, not true.
Because when we multiply straight up cross. So these are equivalent statements. But one separates my constant from my variable. So the same thing can happen here. I can separate my constant from my trig. And now I can just see my trig by itself. Does that make sense?
Yeah. So if you already...
Okay, so what I want you guys to do is to practice these 5 because today was our last day.